Well, good morning. Hello, and welcome to the final day of RIPE meeting in Lisbon. This is the first plenary session for this morning, and we will have three lightning talks at first, and then one talk afterwards before the coffee break. I hope everyone is well rested and well caffeinated for this morning. And with that, I would like to invite Christopher Dziomba, the cloud architect from Deutsche Telekom, to talk about BGP-EVPN to the Kubernetes host. Please.
So, good morning. So we have, in the last couple of years, used BGP-EVPN to the Kubernetes host, and I will be going to tell you today what we've done and how we've done that. So first of all, clicker, there. Okay, that was the laser pointer, sorry. So first of all, how do we use Kubernetes at Deutsche Telekom, and specifically in my team? We have a platform that we call TCAS, formerly known as SIEVE. And it's a Kubernetes platform for cloud-native or containerized network functions, such as the 5G standalone core, telephony services such as IMS, and some OSS systems around it, basically. We have built that with vanilla Kubernetes and a lot of open source components, actually. We focus mostly on bare metal. We do have few VMs, but really it's a bare metal platform, so we have to worry about bare metal networking in the end. And it's becoming the common platform for all of the DT national companies here in Europe. So why am I speaking about Kubernetes at RIPE? And specifically here, well, we all love BGP. I think it's a great protocol. It's also a great protocol in data center. And not only I think that, but also if you know that RFC from, I think it's written by Facebook and Arista, as far as I recall, it is a well-known protocol in the data center as well. And kind of this work was also inspired by a presentation from Attila de Groot earlier in 2018. He did something similar with BGP-EVPN to the host. And the thing is, why are we doing all that? Why are we doing BGP with EVPN and Kubernetes together? Well, Kubernetes pods are essentially layer 3 endpoints. So they have an IP address, they can be fully routed, no one cares about layer 2 anymore. Well, hopefully. Some of the CNFs that we run do require layer 2 because of, well, the vendor ships them like that, or it is just a requirement for some weird protocol on top. And the thing is, we've said, hey, EVPN can actually solve both problems here. It has type 2 MAC IP advertisements, but it also has type 5 host and prefix routes. And it's also well known for virtual machines, for example, the Proxmox software-defined networking, ships, I think, since 2019, as I looked yesterday, also EVPN as an SDN solution. So we are looking at Kubernetes pods now. So I have 2 pods on here, and a layer 3 VNI or a VRF. So what we do is we assign one layer 3 VNI, so one cluster VRF, basically, inside the EVPN to each cluster. And this one is used to establish connectivity between the pods, but also between the nodes. So what happens if we now need to communicate to some, say, outside system or some outside VRF? We actually do local route leaking on the nodes themselves. So we have some kind of data center gateway, border leaf, whatever, that exports as type 5 routes for our backbone routes. And we can locally route leak that on the host. But we can not only locally route leak on the host to establish connectivity to the outside world, we can also do layer 2 VNIs together with any cast gateway to build on the fly, layer 2 networks on top of the host without reconfiguring anything on the network fabric. So how do we do that? So this is kind of our new design. Our old design looked a bit different. We have on the left side kind of a normal Kubernetes installation. It's really, I think we use Calico as our CNI, kube proxy, like it's really, really standard here. But the thing is, we have this HBR container, or also sometimes from our side called containerized routing agent, also installed and sitting on the nodes. We have two options here. Either we supply it directly from the provisioning of that node, so it's there from the beginning. It can do all the connectivity of the node. We don't need any other connectivity anymore. Or as another option, it could be installed later on top of that Kubernetes cluster as well to build EVPN services on an already existing Kubernetes cluster. It takes over, it takes over one of the network cards from the host, and that pairs with our EVPN-ready data center fabric here. One thing to mention is that, of course, this containerized router needs to be administrated, so there can be an API to do that from the local host. So it's not like there is a central orchestration system. It's everything inside the Kubernetes cluster. And one caveat that exists is that the pod, when it needs SIEVE connectivity, like fastpath applications need, we still need to rely, unfortunately, on layer 2 to the fabric. Currently, there are no SmartNICs, DPUs, whatever involved. So, but how does that actually look like from an automation perspective? We have a solution called Network Operator, which heavily relies on Kubernetes custom resources. So this is how you define resources inside Kubernetes. And you have the option to configure layer 2 network configurations, but also the option to configure VRF route configurations. So we cover both here, layer 2 VNIs and layer 3 VNIs. It's now supporting a staged rollout concept. So you actually do it node by node by node, and if it fails, you roll back. And we actually think that we want to go to a pluggable architecture here, because if you remember the last slide, you have this containerized router. Theoretically, it's actually it can be changed to another system if you integrate the APIs with it. So it's also making us pluggable here. The thing is, we currently use FR routing for that, and we are very happy with it. So everything here is open source. You can actually look at that link down below and try it out yourself. However, looking at future work here, so the network operator that is currently merged in main is not completely finalized yet. We can deploy it internally, but there is not so much documentation there that you can easily give it a go. There is a project by Federico Paulinelli, who is like the main maintainer of MetalLB, which is a well-known component in the Kubernetes ecosystem. He has developed OpenPE router, which does something very similar and is actually inspired by this work here. So if you want to try EVPN on a Kubernetes cluster, I highly recommend that one. We also collaborate with the SIEVE initiative, which is a collaboration of telcos regarding open source, Kubernetes, cloud native I'm not sure if it's only EU or also Europe. And we also try to bring that concept, or we are actually bringing that concept to them as well. And we are also looking, because you've heard me talking about that SIEVE thing earlier, we're also looking into SmartNICs or DPU IPUs to actually offload that to a network card as well, so we don't rely on the network fabric anymore that has to be reconfigured. So with that, I'm done. And thank you. I happily take your questions or comments.
Thank you very much. Very interesting presentation. Any questions in the room? We have we have one online.
We have one online from Peter Pompey speaking for himself. The custom resource definition configuration format appears to be an excellent solution. Have you thought about automating provisioning of multiple layer 3 VPN instances at once using, for example, single Kubernetes CRD? Do you automate CRD's creation using K8s API?
So we don't really care if you create one layer 3 VNI or one or more of them, or layer 2 VNIs as well. So it's just the API that is there. If you put more like instances of it into the Kubernetes API, it will provision all the instances as well. Yeah.
I don't think we have any time for more questions, but you can find Chris in the hallway. Sorry. Thank you very much for understanding. Thank you, Chris.
Thank you.
Before inviting the next presenters, I would like to remind you to rate the talks to help us to do better next time, both program committee and presenters. And talking about the recent events, Emile Aben from RIPE NCC will talk about how RIS Saudi Iberian power outage. Please.
Yes, thank you. Yeah, my name is Emile. I'm a data scientist at the RIPE NCC, and this is a talk about how RIS, or Routing Information Systems, saw the power outage here. And locals and others have probably noticed that or have heard about this event happening. So there was a grid power outage here, and I've already seen a lot of talk about what that did to traffic, to the amount of well, eyeballs dropped off, and what you can see, for instance, in this graph from that's the Kix Madrid, traffic dropping here. We also see this in RIPE Atlas. Here you can see the number of connected probes in Portugal and in Spain. They at 10:30 UTC, so it's 11:30 Portugal time and 12:30 Spain time, I think. It's just a steep drop, so no end users, so traffic drops. But I was really interested what RIS, a routing information system, actually sees in terms of how much connectivity was there, how much yeah, how did the internet see Spain and Portugal? So first cut, did the system by which we observe routing, did that see any effects? And yeah, this is a graph from our route collectors. We have one in Catnix in Barcelona. And in total, we have over 1,400 peerings, and here we basically see nothing, right? It just performed as, and I actually find that fascinating. And as you see in a later talk with RIPE Atlas, with Atlas anchors, they experience power outages, so it's more difficult to measure there. So, and for the who here knows RIS? Who here doesn't know RIS? Who is not awake? Okay. If you don't know RIS, check it out, ris.ripe.net, our route collector systems. And if you feed routing information into us, thank you for doing that. First cut, did BGP become quieter, noisier? What's actually happening here? And this is basically, and actually, I was able to do all of these graphs because my colleague Dies de Kock is working on a better way of crunching RIS data, and I'm an alpha tester for that. So and I hope that content will come to the next RIPE meeting. But what we see here is total volume per 5-minute interval, and notice it's a log scale, and I don't see any significant effect on the whole internet. But yeah, BGP is super noisy, right? This is 10 to the 7th updates in a 5-minute interval. So, so what would you expect for an outage? If you have like prefixes going down, you would expect there's less noise here, but there's link instability, so there's updates for specific prefixes, and that creates more noise, maybe. So then I dug down into the per country level of this. Oh yeah, and for context, because I think 3D graphs are cool. This is the AS graph of Portugal to the left, and the AS graph of Spain to the right, and you can see quite a different complexity. And the bigger the node, the more important it is. The home country is in light blue here, and foreign ASs where they link up to the rest of the internet are a different color. Yeah, and this basically is to show the difference in complexity between the two networks. If you then look at the origin ASs for messages we see in BGP, you actually see this effect, which I find fascinating. Before the event, and this is a 2-day interval, all my analyses are over 2 days, so they start at April midnight and they end at 28 April start, 30 April the end. You see a lot more volatility in Portugal, and you see a level shift in Spain. So there's really different effects going on. I don't know what caused this, but I find it fascinating. Then if I just look at the biggest blue balls for each country, so the apex ASs for a country, you see all kinds of different effects. It's like there's not a single thing happening, so there's multiple things going on all at the same time. And then I actually dug down into like, what does this look like for individual prefixes? Were they up, were they down? So each line here is, each line here is an individual prefix, and you can see lots of different behaviors. And these are just 2 examples for Spain. So a lot of it is actually here. A lot of it just stayed up. There was like prefixes were kept being visible from the rest of the internet. Another category, I would say, is prefixes that went down right when the power outage happened. There's some of that down here, for instance. But the fascinating part is the ones where they stayed up for a while and then went down, right? So, and this has all to do with having backup power having backup power or not, and how long did that backup power last. And this is the same graph for Portugal, same type of effect. Lots of stuff just kept, was up, so from the rest of the internet, Spain and Portugal mostly were online. And then I was looking at how did the traditional tier 1s see this actually. So what I actually did in the RIS data, you have like specific BGP communities. Sometimes they're stripped, but let's forget that. For some of the tier 1s who actually tag a route as Spanish or Spain. If I just plot the ones that have the most percentage of this, you can see some fascinating different patterns for all 3 of them. Let me zoom in. For instance, the top one here is Cloudflare via Cogent, and you just see that kept just working. And then, yeah, some other behaviors, some short drops, some where, for instance, the third one here, where the Cogent connectivity drops for a little bit and the visibility also dropped for a little bit. I think these are all fascinating patterns. And that brings me to the conclusion. Well, there's lots of stories about the traffic level drops, and in RIS, we actually see that a lot of the interconnect infrastructure is more resilient than you can see from the traffic levels alone. So, and it brings me sort of like a philosophical thing. What is the internet? And is it, yeah. So in as far as it's the interconnected network of networks, that kept functioning for the whole part. And I hear horror stories here about data centers, generators blowing up. But I'm actually fascinated by the part of this that kept working. So, well, of course, internet needs power, when your grid power goes off, you have an issue. But this needs people, so this needs capacity. This needs people who plan ahead, think. So there was these 6 hours of like when a prefix kept up and then went down. There's a lot of planning to actually make that happen, and also especially for the prefixes that kept for the part of the internet that just kept working. There was a lot of planning on how you would deal with these types of situations, and probably there was a lot of scrambling, acting in times of in emergency, and people who kept their head cool and acted. And what I would love to see is that we capture the stories behind these successes and failures, because this is just the data view of it. It's so much stronger if this also has the stories behind it, what did work and what failed, so we can learn from it. And yeah, so this is actually great that we have the next talk about actually the actual stories of what happened on the ground. 18 seconds left, so that's 14 seconds for questions.
Thank you very much. Well, I have a couple of questions for you, but I don't think I can squeeze it in 14 seconds, so I'll catch you later in that.
Okay.
Always.
Okay.
But thank you. We have, next speaker. So can we leave a question for the no, sorry. So we don't have it. Yeah, thank you very much. So still talking about the recent outage, we heard a lot about BGP prefixes disappearing and everything, but next speaker, Amedeo Beck Peccoz from ESpanix is going to talk about different dimensions of the same outage. The talk is titled Portugal and Spain, Blackout and its Recovery. Please.
Yes, thank you. Hello, everybody. Sorry, how does this thing works? Okay, I found out. So I'm going to give you a view from another perspective, in the sense that I'm going to tell you what the facts, what we've seen, not what has happened, in the sense that not the reasons that are behind the power outage, because I'm not an expert on this topic and I don't really know. I'm going to tell you what we've seen. I'm going to share this with you, and then I will also tell you a couple of anecdotes behind that day, and how we learn to change and to improve possibly for the future. Okay. So what happens on that day? Now we know the time. I put 12:33. That's Spanish time. Spain time. Now 15 gigawatts apparently disappeared in 5 seconds. Just to give you an idea, 15 gigawatts, it's 12 DeLorean, and I hope you do get the reference. It is slightly above 12 DeLoreans. Okay, so it is a lot. The good thing is that apparently France realized that something was not going right. And so they cut, because Spain is connected to France, and Portugal and Spain are connected together. And then Spain is also connected to Morocco. So France disconnected. That's why they didn't propagate going north the blackout. Portugal got disconnected. Possibly the problem originated in Spain, but as I said, I'm not an expert, so I'm not going to say much more on this topic. So what went off immediately? We had anything that works on electricity. Most important thing are trains, tram, metro, lifts, and red lights. Now, this is not just the least. Imagine all the people remain trapped in the underground or locked in the lifts, and everything happens all of a sudden. At the same time, no payment was possible. And also telecommunication services went down. Now, this is completely aligned with the presentation we just heard from Emile, because the access networks went down, but the core kept on working somehow. Over time, so that means in the following hours other services started going down. So the first thing that went down was the cell network. Lasted for 2 hours, the data communication. And it was interesting because you could see that 5G fell first, and then the other G went also down. So in the end, you could only have maybe a 3G connection, and then it also eventually went out. And then after approximately 4 hours, also the calls went down. Small data centers also went down. And the thing is that everybody is prepared to this kind of events for a limited amount of time. So everybody thinks, yes, okay, there's going to be an outage, but the outage will be short in time and will be localized in space. But nobody is prepared for a long time and for a wider space, so a countrywide. Now, this has effects, and we're going to see them. Okay, this is the first interesting episode I'm going to share with you. One of my colleagues was stuck in a traffic jam, of course, going from one place to another one, from one data center to another one. And he was listening to ES radio, which is a local radio. And so the speaker suddenly said, okay, guys, sorry, I got a message from our technicians. He said, we've got approximately 2 minutes left of power to broadcast. And 2 minutes after that, they cut the conversation. So it was real. Okay. So one of the key factors has been the logistics. So you have gas stations out of service, huge traffic jams because the red lights went off. So it is really impossible to refill any tanker trucks. So even if you have a contract, and this is something we experience ourselves, because ESpanix also has a data center, and of course we have a very good contract with a supplier of fuel, and they are bound to provide us fuel whenever there's a shortage. Okay, we have an autonomy of around 1 week. So it was nothing urgent, but still we place a call and say, hey, can you bring us some fuel? And I said, no, no way. Yes, but we have a contract with you. I said, it doesn't matter. It is physically impossible for us to bring you the fuel because the traffic jam is global. There is no electricity to fill in the truck. And normally, we would have taken from maybe a nearby region where there still is power, even if it's, I don't know, a 1 hour drive. Okay, the truck drives for 1 hour, and in 1 hour, you have the fuel. But if it is countrywide, we cannot have a truck coming in from, I don't know, France, okay? So power generators eventually went empty, at least those who were not big enough, okay? At the same time, some other services kept on working. So we have airports and hospitals, mostly, okay? National TV and radio. Now, the thing is that they were broadcasting, but not many people were actually able to receive. Yeah, we found out that everybody has a radio in our cars. So water supply also kept on working. Network cores, as I said, was still functional. And then main data centers, yeah, unfortunately with one notable exception, as far as I know, they kept on working, okay? Now, the situation in the afternoon was the worst one because we have no phone, mobile, and also landline went off, no public transportation, no private transportation, I mean, traffic jams, no fuel for generation. So that's when creativity kicks in. And so these are the interesting parts, okay? In a small data center in Madrid, I'll not reveal the name, they have a single generator, but they pulled out fuel from employees' car. Of course, they asked the employees first, okay? And they said, okay, guys, you're not going anywhere in any case. You know, and the power came back when they have approximately 20 minutes left of power, okay? So they've been lucky, okay? A public water company in Spain, I would also not share the name, they had a tanker truck stuck in the traffic. So they called the police, and I haven't heard the conversation, but I can imagine, hey, we're the water company. Can you send the police to rescue one of our trucks? No. Why not? Well, because we're the police, we do other things. Okay, but then we're going to cut water to the whole population. Okay, then we do it. And they did it. Okay. Yes, satellite phones. So everybody say, why don't you use satellite phones? Well, actually, we do. At ESpanix, we have one satellite phone, which can be used for emergency. Completely useless, because you cannot call anyone except another satellite phone. So either you provide a satellite phone with every person that you need to communicate to, or this is useless, okay? No phone coverage. That was really creative. One of our clients, one of our members, that had two guys in two different data centers, and they managed to communicate over the router management port. Actually, they set a static router to the VRF of the management port. Okay, creativity, goes everywhere. Okay, the last three slides, and then I'm done almost. Reflect the traffic. This is absolutely in line again with what Emile said. The first line that goes down is when we had the power cut, and then it kept on going up and down. The power was restored about half of the picture, which is around midnight, starting from midnight. The traffic still kept on going a little bit down, and then actually recovered the following morning. Okay. We have one of the ESpanix pop that went zero. This is another data center, and they had the zero. You can see the zero. So when the graph goes down, it's really 0, 0, 0. Okay. And then Spanish data center, we remain there. So that's why this is coherent with what Emile said. Okay. So recovery took 18 hours approximately. Someone got it earlier. Portugal recovered anonymously. France and Morocco held Spain. Thank you so much. Politicians had nothing to do with it. That's I say because afterward, all the politicians said, "Yeah, it's your fault. No, we did it good or whatever." No, guys, you did nothing. Okay. What we've learned: change the Spanish contingency plan. Now, in case of power failure, the important people of the company have to go to our data center, and in case of power failure, we communicate with our customer portal, of course, if we can access the customer portal. Okay. And that was it. Thank you.
Thank you very much. Fascinating presentation. But unfortunately, we don't have time for more questions again, but we know where to find you. Okay. Thank you very much. Well, now we're talking about outages. Let's talk about outages in the sea. And Emile, again, thank you very much, and his colleague Joaquin Vaquero Ortiz from RIPE NCC are going to talk about how the internet wraps around damage and what RIPE Atlas tells us about submarine cable outages. Yeah. Please.
Okay, yeah, thank you. Yeah, Emile again, my apologies. But this time I'm joined by a fresh face, my talented student, Joaquin, and we're going to tell you about the collaborative work we did on how the internet routes around damage, in this case, cable damage in the Baltics. Yes, first, we published 2 RIPE Labs articles on this already. Yeah, so if you want to have more in depth on this, that's the place. And it could also be a great place to collect the stories about all of these outages and stuff happening. So that said, the Baltic Sea, with all of the things going on the internet, you might have forgotten, but there was actually a couple of months in November until January when there was a couple of Baltic Sea cables that had damage. And this is a timeline of the things that we analyzed. And as you can see, we focused on these 3 cables. One thing that you can notice here is that cables have an outage. And in this case, there was probably a lot of repair ships in the neighborhood. They got repaired quite quickly. So a lot of media coverage on this, lots of speculation. And if you were in the cooperation working group yesterday, you also saw a nice presentation by a retired Navy captain, with more depth on the vulnerability of these cables. Also speculation on if this was sabotage or not. And on the other hand, I also hear stories from mostly the cable industry saying, yeah, cable damage happens all the time. So we plan for this. We know this happens. We have repair ships. Maybe to disappoint you a little, this talk will not have any new information about was it the one or the other. What we actually do is we try to use neutral data to see what the effects of these types of events are. So we use RIPE Atlas, surprise. And I'm guessing there must be at least 100 RIPE Atlas probe hosts in this room. But for those who don't know this, it's a very big measurement network, over 13,000 nodes. And in this case, for the measurement, you have the global pictures actually here where we are deployed now. Out of these, we have over 800 anchors. And these are super interesting, like the bigger measurement devices, because they measure in a mesh. So anytime a new one comes online, all the other start measuring towards it. And so we basically have a good global mesh of all kinds of latency and traceroute data about the internet. So that's a really rich data set. And we did dig deeper into that data set specifically. And how we did this is, for these events, we take the anchors in one country and then in another country, and well, that's typically the two sides of a cable, and just see what in this case the latency data, the ping data, tells us around the time of these events. So it could be that, for instance, if you look at Finland to Germany, that routes go via Sweden, like this way. So not necessarily via the cable. And another thing to notice, the orange dots here are actually the locations of the anchors. And the table here has the number. It's really nice to have a larger number of anchors here, because then you get if the number is too low, your data becomes a bit more anecdotal. So Lithuania had 5. That's like borderline of what would be nice to have for these types of analysis. So yeah, first 2, and then we created some visualizations. And then now I'm handing over to Joaquin, who's going to tell you all about how these visualizations work. So here.
Okay, 1 second. How do you do that?
Yeah, this and that's the
perfect. Okay, thank you for the introduction. And now we'll go over the first event, which was a BCS East-West cable outage. And before I start, I do want to explain what these graphs mean. They have quite a lot of data and graphs in general, so I want to go over them. First of all, to keep in mind, on the x-axis we have, I don't know if you can hear me well. On the x-axis you have time, roughly 12 hours before and after the event. And on the y-axis you have paths between anchor pairs. And you can see that the darker the color is in the graph, the higher the round trip time latency increase over the baseline. So that, yeah, we just normalized across paths. So now that we know what this means, we can see where the event happened. There's a clear shift in latency across around 20% of the paths. And yeah, we will go over the graph at the top of the plot. In orange here, we can see the average latency increase at each time step, combined with a plot for percentage loss. And here, if we look at this, we can see a clear step or increase in latencies overall. But we do not, clear to point out that we do not see any sort of increase in packet loss or significant increase in packet loss at this time of the event. So continue. I wanted to zoom in a bit more into the graph. It may be a bit daunting at first to kind of visualize what it means. But here we zoom into a line we can see that here, the lighter colors are basically no increase over the baseline, or very little increase. And then if we move on, we can see how there's a clear jump, and here it goes to a bit of a darker color. So yeah, hopefully this paints a bit of a clearer picture of what this means. So we'll move on. So this is the next event we're going to talk about, which is a sea lion cable outage. This event, we can also see a very clear jump in latencies across paths. This event happened at approximately 2 a.m. UTC on the 18th of November, approximately 1 day after the previous event. And yeah, we can also see, if we look up top here, we can actually see also a giant, well, not giant, actually it's kind of pretty small, but a small step in latency, but we also do not observe any sort of increase in packet loss either, which is surprising. And also, if you wonder what this is probably some congestion over here, but we don't have any like clear evidence for this. It's just speculation at this point. So moving on. Sorry. Yeah. So this cable was repaired on the 28th of November at around 7:30 UTC. The repair ship cable announced a successful repair. And here, your eyes may be drawn to the large spike over here in loss and latency. You can see there's around a 20% loss, packet loss, which is quite a lot. We don't actually not know what this means. So if there are any optics or undersea cable experts in the crowd, we'd be happy to have a chat with you guys. Maybe we can clear up some doubts, or you guys could explain what it means. But yeah, what I actually find fascinating about this graph is that we can see parts of the mesh slowly going back to the baseline latency, probably being rerouted through the repaired cable. Also, we don't really know this for sure, but eventually all the paths go back to their baseline latency. So yeah, moving on. So summing up, we did see an increase in small but visible increase in latency across around 20 to 30% of the paths for both events. But we did not see any sort of visible or noticeable increase in packet loss. So yeah, in conclusion, the internet rather around the damage. A clear testament to the resiliency and adaptability of the internet, at least in this part of the world. But we will see later on that this is not really always the case. Resilience is not always guaranteed. So yeah, also moving briefly away to what we talked about before. Yeah, we've been trying to adapt our measurement techniques to other types of events. We've been doing cable outages, but now we wanted to shift towards power outages as well. Here we can see the data from the Spain-Portugal power outage, and here we created a mesh. We created a mesh with Spain and Portugal, and we combined them as if they were their own, like, one whole entity, which kind of gives us a better view of the event. And here we can see that there's not really much going on right after the event for a couple of hours, which suggests the use of generators or backup power supplies. And after that, we do see a lot of anchor loss, which is this whole gray blob, this brings me to the point that these types of events, at least measuring them with the anchor mesh or analyzing them with the anchor mesh, is not really feasible, just from the fact that the infrastructure we use to measure these events is taken down by the event itself. So yeah, it's not really ideal, but Emile will go a bit further into this now. So yeah, I'll pass it on to Emile now for the deeper dive.
Yep. Thank you. Yeah, so we did a second RIPE Labs article where we, all of this until this point was based on latency data, ping data. But we also have traceroute data, right? And that's, so we have IP addresses in the path between our anchor nodes. And so we can actually do a deeper dive into, how to get a sense of how things were rerouted and what types of things we can see that could explain some of the resiliency. So we divided this up into basically three different types of things. Like it's the interdomain rerouting. That's your classical BGP. Like a route goes down, you have a backup path, and stuff gets rerouted. And you can see this in if you look before and after the event and just compare the sets of IP addresses. You can do an IP to AS. You can actually see the AS path between two nodes changed. Second is intra-domain rerouting. There you don't see different ASs in the path, but you see different IPs in the path, so that so something within an AS broke and the AS rerouted around that. And the next one is a circuit level rerouting. That is where we see a latency shift, but we just see the same IP addresses in the path. And long story short, we saw all three of these. So if we take like a 3 millisecond cutoff, as that consists of a significant latency shift, we see, here you can actually see the ECDFs of all of these. More details in the labs article if you're interested in this. And another thing we did was look at other events. Now we basically have the methodology, but RIPE Atlas data goes back years, right? So there was a really interesting event of a submarine landslide. So that damaged a lot of cables off the coast of Africa. So now we have enough anchors in South Africa, and we have anchors in the UK, and they are probably routed through these cables, right? So we can actually see what happened. And this is a rather messy picture. The line gives the time of the event, and as you can see, oh no, wrong button. Here you have, and if you look at the axis, there's significant packet loss here, and this is like 40–60%. So this is a case where, where we see a latency shift that is accompanied by packet loss. So it's resilience not guaranteed. In conclusion, internet router around damage, and we actually see there's 3 levels of rerouting happening, and we see all of them happening in the case of the Baltic Sea. The cable outage is there, to actually get a better picture of this, we would like to keep monitoring this, measuring this, understanding it better, and for that we are really happy with the RIPE Atlas coverage. But also in some locations we would love to have some more. So we actually are now looking at, like, if you look at this on a country level, we would like to have a certain level of a baseline of deployment, especially for for countries that have cable landings. And so we created this. It's an online tool we have, and in this we have the number of landing points per country. That's this column, and then we just like a straw man minimum deployment is 5 anchors in 3 different locations in 3 different ASNs, and then if you have that for a country, then it lights up green. So we have a lot of green countries in this part of our service region. Have to point out Portugal. So we have anchors in 2 cities, not 3. So that would be great if you could actually up that, or figure out that it doesn't make sense to have, because everything in Portugal happens in Lisbon and Porto maybe. There's another one for so that part of the Europe part of our region is quite well covered. The Middle East part is a bit less so. So for those who are able to deploy RIPE Atlas anchors, we have Michaela sitting here, who's in charge of that, and she'd be happy to talk with you about deploying new anchors, specifically in the countries where we don't have this this diversity yet, because we'd love the diversity in this. And that brings me to the questions. So thank you.
thank you very much for another interesting and useful presentation. And I see, well, we have questions in the room. Let's go ahead.
Will, I'm sorry, this is going to be a comment. Happy birthday, Emile.
All right, other questions from the audience in the room or maybe online? So that gives us a few extra minutes for the coffee break. Thank you very much for attending this session.
Just a quick reminder that we will have the GM election results announced during the coffee break. So if you'd like to grab a coffee and come back for that.
And also PC election results.
Hello. Hello, and good morning, everyone. Welcome back to the general meeting. If you go find your seat, it is now exactly 10:30, and I would like to get this over with. Freedom looms. This is the last splash. Here is. Are we happy over there in the back? Are we just lingering? You're all good? Ready to go? Yes? Excellent. Here's the voting report of the general meeting. Well, this is going to be rather dry. Resolution number 1, the general meeting adopts the NCC financial report. Yes, 876, no 92, abstain 71. The motion was approved. Resolution number 2, the meeting discharged the executive board. Resolution was again approved. Resolution number 3, no, I'm not going to read it out completely again, again approved. Resolution number 4, more amendments. Resolution was approved. Number 5, unsurprisingly, approved. Number 6, you can see a theme here. It was approved. Number 7, more conflict arbitration procedure. The resolution was approved. Let's see what happens next, right? Resolution number 8, it was approved. Now comes the really exciting bit. Resolution number 9 adopts the charging scheme 2026. It was approved. And that was it, right? No? Oh, okay. And then I guess the moment you've all been waiting for, and my last step towards freedom. The executive board election. Congratulations to our newly elected executive board members, Randy Bush and Ondřej Filip. Congratulations. Good luck and Godspeed to both of you. And with that, I declare this general meeting closed. I'd like to thank Jeff Houston from APNIC as the independent observer. That's it. I'm out.
Right, good morning, hello. Welcome to the closing plenary session of RIPE 90. Could I ask people to take seats or take the conversations outside or whatever works best for you that doesn't involve chatting in the room? I will start naming individual people who I can see chatting at the back of the room, Tobias, who is just not listening to me at all, so that's fine. Anyway, yes, welcome. I'm Brian, and along with Max, we will be chairing this closing plenary session. So a couple of things to talk about before we move on to the excellent lightning talks that we have. First off, I'm going to do the announcements at the beginning because the end of this session generally gets a little bit fluid. So just to remind people that the RIPE Nomcom will hold their office hours during the second half of the lunch break from 13:15 to 1400 local time. So it's the room Castanea up on the first floor to speak in person to the committee. And the other thing is just also you can still share feedback on ICP2. We could talk about it again, but you know it's been mentioned once or twice this week. But you can share feedback on ICP2 from 13:30 to 1400 at the meet and greet desk, as presumably the entire meeting is torn down around you in a sort of Miss Saigon sort of way. So what else? We have one more election results to announce, and just to say that the result of the PC elections. So two spots, and both Clara Wade and Amedeo Beck Peccoz were elected. So thank you so much to everyone who put themselves forward. We hope that you will continue to do so. Maybe think about standing again in the future, because it's really important to get people in to the PC to do all the important work that needs to be done to build the meeting. And of course, do rate all of the talks so the PC can understand what you would like or don't like for future meetings. So I think that's all of the administrivia. And the bell has happened now, so lots of people have come into the room, which is all good. And so we'll move on with the meat, the content of this meeting. And first up, we have, and hopefully maybe some slides, we do, excellent. So we have Ondřej Surý from ISC talking about sieving. Please.
Hi, this is Ondřej, ISC again. So first of all, the algorithm isn't my work. It's work of young researchers called Yezhuo Zhang. She is postdoc at the ETH in Zurich. So I don't want to be another man taking women's work for my own. So I have merely implemented this in Bind. So without further ado, so RU, least recently used algorithm. This is a software engineering talk, but it's interesting research, so don't run away. If you have a cache and there's a cache miss, you just evict something that's at the end of the queue or buffer or whatever and put it at the beginning. That's the normal RU. On cache hit, you just like move it to the beginning and you go on. This is this disadvantage that for both of these operations, you need to lock the list, which halts the other threads or other processes that wants to use the same cache. For the SIEVE, on the cache miss, there's this algorithm that there's a little hand. It's called SIEVE hand, and it looks at the space in the cache, and the yellow one is like visited flag. So if it has a visited flag, it just unmarks it and moves on. And if there's not a visited flag, it just evicts it, same as RU, and it needs locking, and it puts the stuff at the beginning of the queue. However, on the cache hit, it just like raises the flag. So we are trying. There's a request with A, and we already have A in the cache. So we just raise a flag, which means we only lock the individual item. It doesn't have to be even lock. It could be atomic operation or something like this. And what's the effect of this? By the way, there's a long video of how this works with more examples on the algorithm webpage, which I invite you to read, because this is like lightning talk and I don't have much time. So it has these two properties: lazy promotion. So it only promotes the cache objects at the eviction time. So it delays it to the last possible moment, so it doesn't slow down the fast path. And the other thing that's important, the other property is quick demotion. So it removes not like objects that has been inserted quicker than the one that lived in the cache for a longer time. These are both, there's a paper around this, and this is really like exciting research. So what's the effect? And so I did an implementation in By9, and as you can see, well, it's much shorter than it was before. So I only like added 144 lines but deleted 400. So the algorithm is simpler and it's much more efficient. So this is By9. This is our test lab. If you haven't been to my other talks, I just quickly explain what this means. This is reverse logarithmic graphs. So basically, you want the lines to be as to the left and as to the down as possible, because on the y-axis there's like seconds, and on the x-axis is the reverse logarithmic percents. So which basically means that the straight line at the bottom is stuff that has been answered under 1 millisecond, and for the orange one, that's the original algorithm, the original RRU, it like you probably don't see the numbers, but there's this little number 7 at the x-axis, which means that 93% of the queries were answered under 1 millisecond, and go on. So at the top, there's like, it matches the number 1, so it means that 99% of the queries were answered under 2 seconds. But as you can see, with the new algorithm, with the very small cache, like 128 megs is not a big cache for DNS. You should not run DNS with such small cache, but you can. It just pushes the limits to even farther. So 99.6% of the queries were answered under 2 seconds, and 96% were answered under 1 millisecond. So there's like 93 versus 96. There's like 3% difference just by changing the cache eviction algorithm alone. And this is cold cache. So there was nothing in the cache in the beginning. For the hot cache, wow, the effect is even stronger for the small cache. Again, you want this to be as to the left and as to the bottom as possible, and I think this shows that like how good the algorithm is for DNS caches. And the memory effect, again, it helps. And this is a CPU. As you can see, it's not so, the orange one is the original algorithm. It was so spiky. So we were doing a lot of work evicting stuff from the cache. And now it's like more, it's less spiky. So it means that the CPU is doing less work in these cases. For the, the normal 30 gig cache, there's a little bit effect because there's a little bit less locking even on the, even when you are not doing the cache eviction, because it's not needed, because we didn't fill the 30 gig in this test. But there's still some like small effect that helps with the normal operation. So the hot path is, doing less stuff. There was the cold cache. This is the hot cache. For the hot cache, there's no difference basically. Yeah, the memory, CPU. So what's good about this algorithm? It's not like something that you just exchange RRU. There are a lot of, if you dive into the field of the cache eviction algorithms, there's a lot of them, and you can actually like use SIEVE to to help even those other algorithms, if you replace some of the internals of the other algorithms from LRU to SIEVE, it helps even them. So this could lead to even better algorithms in the future, but itself, the simple one is much better than the original LRU. The one thing that it's not suitable for everything because it's not scan resistant. Because when you like raise the visited flag every time you visit, and if you scan everything, then you set a visited flag on everything, and then the algorithm doesn't basically work. But there's some there was some talk about this, how to solve this, like not have just flag but a counter and stuff. So there's the option to have like future research in this area, and this is it. And the applause really goes to the algorithm author, not me.
We have time for a question.
Yeah, this is Shane Kerr, IBM. Did you measure cache hit ratios with this? Because it changes the heuristics, right?
Well, it's the same data set. So, what?
I mean, you're picking a different thing to evict, right? That's
yes.
Yeah. So it might be better, it might be worse in terms of the actual usage, and that's what you didn't see. I didn't see that measured. So.
But basically, this means that more stuff has been answered. So we don't have the metric to measure the cache hit ratio.
I see.
But I think we can deduce from this and this that the cache hit ratio is better because there's less outgoing queries because you answer these from cache because they are much faster.
It's a plausible explanation, but I would like to see data.
Yeah,
anyway,
I get your question, but we don't have that metric. But I think we can deduce from this that, yeah.
I don't see any other questions, and we're running out of time. So thank you, Ondřej. So next up is a person I just saw entering the room right now. It's Alex Semenyaka, telling us about an experimentation he's been doing with Android and you go on stage. In Ripatlis.
I have some questions for the audience, and I rendered them as a presentation. Where is the clicker? Yeah, I see. It started a couple of months ago when Google announced that they added a native Linux terminal to Android to these Pixel devices. And I had exactly such a thing, so I decided to take a look and how it looked like. You have to, to enable this option, install the Linux terminal, and it was just a normal Debian 12. So I decided to take a look a little bit deeper, and I found that it is a virtualized environment, whereas a lot of functions are available in the virtual state. It's like a virtual machine inside this guy, and it's not the only possible thing. It's a whole framework to do such things on the modern Android. But with this terminal, obviously, it was possible to create raw sockets, to play with a little bit with the network. So I decided to add some craziness and to check if it's possible to install the Atlas probe on this device. And I went through the standard process. It was easy. It took like 3 minutes. And I found that, yes, I can do it. And actually, I know that I had a lot of discussions for the last probably 5 years with different people who were interested in such thing in the mobile probe. And actually, yeah, sorry, the illustration that it works. This is my probe. I am brave enough to show the probe number because I'm going to shut it down. But you can check, the geography, for example. Yesterday it was France because I'm using the mobile internet from French Orange. But yeah, the day before it was still Lisbon. So all these discussions went to this section on our site, where we are expecting that we are not supporting such things, and we will not. However, to be honest, we are living in the mobile era. That's true, and probably with 5G we will have less these home devices and more different, mobile things. And I decided to reflect a little bit on what's going on here. Actually, right now, with this decision, it was completely fine and correct like 5 years ago. But right now, we already have some experiments with that. For example, in Rotterdam, my friend from Paris, Louis Pitignon, delivered the talk how they installed the software probe onto Linux notebook, and they did mobile research going through the Central Asia and making different measurements in different places. So it's already here, and basically we are losing the capabilities from mobile world, like a number of mobile devices and different pieces of information like GPS. GPS is not available in this virtual terminal, for example. So people probably will still do something under the table, which is not that good because we have contaminated data. We don't know how to interpret them in proper way. And simultaneously, we have this additional information that can be useful for us. So I decided to ask the question, do I need to go this direction? It doesn't mean that I'm proposing to go this direction. I mean that it's necessary to think about it, but think about it with all aspects in mind. And some arguments listed on that page was like battery drain. That's completely valid point, but it's not necessary probably for such thing. It's not necessary to run probe all the time and have a permanent connection. Probably we have rethink interaction with controller and use different scheduling strategy, and probably user can choose among them. So it's not the huge issue. It's still important thing to remember, but it's not a showstopper. And of course, this data, because it can be connected, as I said, it was connected to this network, and it was in Lisbon. Then it was connected to French network, and it was in Paris. So this obviously these things should be treated completely differently, and even might be that researchers have to explicitly ask for this set of probes to use them, and they should not be probably should not be mixed with other probes. Might be, but here it's again something to think of. It's not a showstopper. And we have the toughest part actually, how to realize that, because using this low-level thing with a non-virtual environment is not that easy, and Java does not support it. So either we have to go for the bundled applications, And it means that we are losing a lot of parameters we have now in RIPE-Atlas probe, because bundled application does not allow such amount of parameters. Or we can go for the combination of some virtual binary and non-virtual binary. Virtual binary will do this packet stuff, and the second part will take care of everything else, but it's quite a difficult architecture. And the last option go for native development kit, which is really, really hard to use. But there are some guys who tried and succeeded. For example, developing native traceroute for Android, so we can use their probably their code a little bit. But it's still not easy, and there is a lot of work. So I gathered some pros and cons. First of all, as I said, I don't want to be tracked because I have this mobile probe. So probably if you go this way, the way to gather data and provide the results to researchers should be completely different in some aggregated style, without any probe IDs, of course. And the parameters we can use probably will not be that that rich as we used to have, sorry. And we should not expect that one probe will provide a decent number of results. It will be results from different probes, and they have to be treated correspondingly, so it's not that easy. But from other side, we will have such information as GPS, so we will be able to geolocate networks, for example, in the direct way, that what Google and Apple are doing all the time. But we have no such capability, and might enrich our data, and we can add lag, this base station information, and so on. So it might be really useful for different researchers, and it can open for us the opportunity to cooperate with mobile virtual researchers and mobile operators, and maybe even, I don't know, regulators. I'm not sure about this step, but might be. And with the number of these devices, much larger coverage can be provided. So pros and cons, and if we go this way, it's a lot of work. It's extra money, and probably it's reasonable to to volunteers to jump in and to help that. To do that, because it's completely different world for Atlas team. So just presenting what I have in my mind. That's it. If if you have any opinions, probably please express them in our mailing lists to continue this discussion and to make a decision well grounded.
So yes, thank you. So as Alex said, please do engage on this. There is no time for questions here, though, unfortunately. So yes. So to move on to the last lightning talk of this session, we have Anna Wilson telling us how to be a little bit smaller and how not to get overwhelmed. Please.
Thanks so much, Brian. Maria Farrell's talk on rewilding the internet was the perfect opening for this meeting, wasn't it? I mean, I've been hearing people talking about it all week. That's exactly what you want. And here's the thing. Over the course of the meeting, as we've been talking about things that we can do to help, I've started hearing a lot of reasons why we can't help. Company A is too big. All my friends and family use app B. We're never going to be able to prize control out of the grip of platform C. And it reminded me of a talk at a RIPE about 10 years ago by someone who looked a bit like me, but had a different first name, and her gender wasn't quite finished yet, which touched on disruption theory, Not disruption like move fast and break things, but this is about how huge, unstoppable incumbents can be entirely obsoleted by competitors that are small, strange, and worse. The lesson here is there are things that large companies can't do even if they want to. Here's the 90-second explanation of disruption theory. Look, I'm going to talk hard drives. Time is on the x-axis, drive capacity is on the y-axis. Clayton Christensen saw that mini-computers typically ran using 8-inch drives. And over time, those drives got bigger, and they got bigger faster than mini-computer customers needed. That's good, right? You want the technology to be improving faster than your customers' needs. And then the manufacturers of those drives started to develop smaller, slower 5.25-inch hard drives and tried to sell them to their existing mini-computer customers who weren't interested. Why would they use something that's like slower and crappier? Maybe it's a bit cheaper, but it's not enough, it's not going to make a difference to the cost of a mini-computer. Their existing customers wouldn't stand for it. So that left an opening for a bunch of small companies to make personal computers. And compared to mini-computers, these things sucked. They were trash, practically toys. You could not use them for serious work, but they bought the 5.25-inch drives. It was, less money in the industry. But what happened is that personal computers got better faster than mini-computers got cheaper. And that wasn't a technology issue. That was a business choice. The mini-computer makers were trapped into chasing higher profits per unit, so they kept trying to improve their product far beyond what was useful to the customers until the PC got good enough for those customers and everyone switched at once. That's disruption. When a company gets big and profitable, there are things it becomes incapable of doing. But we already know this because we've done it too. We're networkers. We work in layers of abstraction. Jeff Houston is here somewhere, said the reason the internet took off isn't because it was the first way to send messages or pictures or even video over the phone line. It's because once you connected your modem, you didn't need permission from the phone company to run any application you wanted. We built a layer independent of the layers below and which others could use to build the layers above, but there are more layers out there than this model. If you haven't seen me around the last couple of years, it's because I was spending some travel budget going to software development events. You can learn an enormous amount about our networks from the ways that developers use them. The end-to-end principle at the IP layer isn't really important to them. They have their own networking model, and it looks like networks of servers or containers fronted by load balancers and DDoS protection, serving client networks covered by NATs and NAT-PT devices. And yet, because everything is layers of abstraction, they've still found ways to pull off global end-to-end communication. Innovation is still happening. I think a great example is web push. This is just a regular web standard. Web page can, with your permission, wake up your device, send you a notification, and then the web app in your browser in JavaScript reestablishes communication, and you have an end-to-end link again. That is way more straightforward and power efficient than trying to maintain an always-on IP connection with every device on the planet. We don't need to fix every layer in order to fix one layer. That is literally the concept of the TCP/IP. And outside of this room, there's way more layers out there than we think of in the OSI model. Web standards alone move way more quickly than anything we do. In fact, if you're not already following web technologies, I'd say start. Not because you're going to be programming with them, you're not going to be deploying them yourself, but so we can understand what modern applications look like and how their network needs keep changing. The same day, last Monday, that Maria gave her talk on rewilding the internet here, a new version of Safari came out, which had an enhanced version of web push, an enhanced version of standard to make it easier to use. I got interested in all these crazy things like, web technologies and aviation safety and improv theater, because I think that the very best results happen when disciplines crash into each other. And that's the thing large companies can't do. They've become a really amazing machine at their specific discipline, and they're incentivized against following up on things that might lower revenue. But I really wanted to come up here at the end of the week and emphasize this, because I'm going to tell you, please forgive me, Maria, if you're watching, and I know you are, I'm going to tell you the dirty secret of public speaking. It kind of doesn't work. I mean, it feels amazing standing up here and, giving a talk that gets huge applause. Thank you in advance. And, people are talking about it afterwards. But talking isn't doing. It's very rare for someone to give a presentation that actually gets people to stand up en masse and start doing things differently. Maria's talk on Monday is the closest I've seen in a very long time. I heard the reactions in the room, and so did you. But if we spent this last week persuading ourselves that we, the people in this room, the people watching on Meet Echo, can't find any way to help, that is an enormous lost opportunity. I was lucky enough to share a stage with Maria 9 years ago, and I said this: for the specific things that we do, it's not just that we can help, we're the only people who can help with that thing. And any one thing we do is not going to be enough. We know that. But remember what else Maria said. Building an ecosystem is not just about planting seeds. It's not just about growing your patch. You build ecosystems by connecting them to other ecosystems. And there are so many interesting ways to connect ecosystems these days. If you have something in mind that you'd like to do, and if it feels hopeless because the biggest companies in the world have employed legions of really smart people to just dominate that sector, remember there are things they are incapable of doing even if they want to. So start planting your garden. And then whatever you do, connect it to others. Good luck. We're counting on it.
We have time for just one quick question, if anyone has. I don't see anyone. Do we have any on Meet Echo? No? Well, oh.
Blake Willis, just a quick one. Thank you. This is super well aligned with the theme of the opening. I'd love to add to that. The internet is the only utility. It became a utility by accident. And it's the only utility ever designed without someone going, where do we put the billing meter?
Well, thank you very much, Anna.
Thanks so much.
That was really interesting. So next up, we have the Code of Conduct team giving us a report. And Rob will take the stage.
Am I on? Hello. It's a quick update from the Code of Conduct team. Every time I do a presentation, I sometimes learn how to make my presentation better for next time. And what I learned, I was going to give this update in Prague at the last Right meeting, and what I learned there was your presentation would go a whole lot better if you were actually physically in the room when you were supposed to do it. And of course I was sitting somewhere outside and focusing on something, and then my phone went ping. Rob, where are you? Of course I ran to the room to find Francesca had got up and done the presentation that I was supposed to do. So sorry for that. Okay. How do I move on there? Oh yeah, press the button. Okay, this is an update from older cases, that reports we've received. So before this meeting, there were 2 cases that we had open, and those have now been concluded. We did get feedback from one reporter to say, thank you for doing that, but you took way too long because it was quite slow for us to respond. Yes, I think we're too slow. And I think a lot of what I can see is we're quite slow sometimes because we want to make sure we're following the process correctly and we're being sure we're doing the right thing, and it takes some time. You have to talk to somebody else or wait for them to reply. So if we go away from here and have to do things over email or calls, then yeah, it's quite slow. But you know, we picked up on that, and it's all quite new still, and we're getting quicker at responding to things. It's much better if we don't leave people hanging and we reply as soon as we can. Both cases were concluded. We decided at the time that they were a violation of the code of conduct. One was a violation of the yellow lanyards, the photography policy, and one was what I suppose what you could categorize as bullying, and those have been concluded now. So Right 90, we did receive one report during Right 90, and we followed the process and looked at it. One team member, I think, we thought there might be a conflict of interest, so they were not involved in this report. We contacted both of the parties involved, and we've concluded it during the Right meeting. So we just made the subject of the complaint aware, and they acknowledged their behavior, and it was, they didn't realize that this was a problem, and so they've agreed to take action, and so we didn't then take any further action. So yeah, if we can deal with it during the Right meeting, it's much faster and easier. What we find a lot is, though, people don't necessarily report it during the Right meeting, but they will report it after. We'll get an email maybe in 2 days saying, you know what, I've now reflected on this, and I don't want any sort of serious consequences, but maybe you can just have a chat with this person to say, that wasn't cool, can you not do that? One of the things we noticed were voices from the community. This is kind of interesting in what people have been telling us, whether they made a report or not. These are all different comments we picked up on. It was a very unpleasant moment, and I just wanted to forget it. As a newcomer, I did not feel entitled to use the tools and mechanisms in place. It was unclear to me what reporting would mean in terms of exposure, next steps, and to what extent I would have to share what had happened. I wasn't sure if I will make a report. I think someone came to me and told me that somebody had spoken to them and said, oh, I've just spoke to somebody who was thinking of making a report. And what they said was, well, maybe the moment you start thinking about that, probably you should report it. And the last one is, maybe because I studied at university where there were only a few women and a vast majority of men, I'm quite used to some jokes. It didn't even cross my mind to report it. And so we're listening to all of this, and it's trying to find that balance. We would like the code of conduct to be a little bit more visible, especially to newcomers, and is a little bit striking that balance between being visible but not over the top visible, if that makes sense, and just being present but making people aware that we're here, but not being over the top with it. And I suppose I could make the analogy that if there was a small fire on this stage right now, what would I do? Would I be able to put out this fire myself? Would I be confident to do that? Or I could go to the back of the room and press the big red button there. And both of these things are a good option, right? Somebody else might not be confident to tackle that small fire. They've maybe never had to do it before. So they go to the room and press the big red button, but then maybe hesitate and think, I don't know what's exactly going to happen when I press this big red button. Are all the alarms going to go off? Or is it one of those quiet alarms where the hotel will send somebody up quietly just to check it out before everybody? So it's that not knowing what's going to happen when you press the big red button. Both of those are completely acceptable options, but the hesitation to press the big red button. But what happens if I do neither of those things? I didn't feel confident to tackle the small fire. I didn't want to press the big red button either. And that, in a similar way, is sort of the code of conduct. Do I make a report? Do I say, oh, I can deal with this myself? I don't need to involve anybody. I'm quite used to dealing with this myself. What happens if neither of those things happen? Maybe a smoke detector will go off somewhere. The system will detect it automatically. And that is like the community, maybe somebody else in the community saw what happened and went, so yeah, and what do we do about that? And so it is things we're thinking about, taking all of that on board. I want to think that we're not the big red button. So please don't think of us as the big red button, and don't worry about what's going to happen if you make a report, because we really want you to feel that if you want to, you can. Don't think of us like the big red button. Don't worry about what's going to happen if you make a report. All things we're taking on board and listening to. How do you report? Hopefully you've seen these posters everywhere and on the website. And there's actually a web form you can fill in, or you can send us an email. You can just go to an individual team member if you would prefer just to speak to one of us individually, that's fine. And we all have email addresses on there which are private to us. Nobody else can see that, so you can. That's another way. So it's up to you if you want to report it to the whole team, or you can just talk to one of us individually. More information, right.net/COC. Code of conduct team, who are we? There we are, friends. I don't know, we got a new person this time. Is he in the room? Theo, so welcome to Theo. Yeah, that's who we are. We're looking for new people to join the Code of Conduct team. Randy, as we just heard, is now elected to the executive board. So congrats to Randy, but that now means he will be leaving the Code of Conduct team. So thank you, Randy. We'll miss you. Yeah, so we are potentially looking for people. We've done, since the last RITE meeting, we've done a bit more training with an external training provider. So we don't have to do it all on our own, and we'll figure out. So it's made us a bit more confident, both to sort of onboard new people to the Code of Conduct team. It's given us a bit of a refresher, maybe a little bit more confident in how we're applying the process, and speed us up a bit. Expect QR codes. Expect a very short survey at RITE 91. We do need your feedback. I think that's it. Any questions for me now? Or?
Yeah, well, first of all, I think thank you for the work that you and all the team are doing. Very, very important, and I really love that analogy, by the way. That was, I think, very useful. We have time for maybe one question, please.
Is it on?
Tobias Silich, Max Planck Institute for Informatics, speaking for myself, and I would like to remind the community, just because we have a code of conduct team doesn't mean that we are absolved from our duty to act when we see something, to report to the code of conduct team, and to continuously keep doing the right thing to keep the community we want it to be.
Okay, thank you very much, Rob. And now the presentation you've been waiting all week to hear. So, we'll be giving the RIPE 90 technical report. Ooh.
Hello, everyone. My name is Ondřej and I'm very proud to be on this side of the stage. I started 7 years ago to be in the tech team, and I started like pulling cables and taping them down on the carpet. I still do that, but now I also get to report, to do the presentation, basically. Yeah. So last time we were here was in 2009. I wasn't around, but I found out some things are exactly the same. So we got an IPv6 assignment dedicated to the RIPE meetings, and we are still using it. We have the same flight cases full of tape, and yeah, we still eat a lot of pastel de nata. The technical team. This is the technical team and the event team. We work very closely during those weeks. They are a group of amazing people, and many of us come from different departments in the RIPE NCC, but we come together twice a year to make all this possible. We do some preparations in advance. Once the venue is decided, we start with a site inspection, which is almost 2 or 3 months in advance. That means we check the hotel infrastructure, and we look at the meeting rooms, and we test the patching ports. We also do an inventory just before, like a month and a half in advance. So we test all the equipment, we check that everything is still there, and we update our servers, and we also ship the router and the switch to the hotel so we can get the connection running before we come here. So as we get closer to the event, we ship the flight cases with a courier. In the picture, you can see our heavy lifters who help to load the truck. The weekend before the meeting, we come to the venue, and we start setting up. During the Friday, we usually get the network started running, and then the Saturday and Sunday we set up the presentation system, and we do the last things. Usually on Sunday afternoon we have a rehearsal to double check everything. This is the list of the equipment that we bring. It fits in about 14 flight cases. We usually start with a very tidy inventory, but by the end of the week, this is how it looks like. So everything around the ops room. So this time, speaking about the shipment, we got a little issue with the delivery. The truck with our kit took a while to arrive to the hotel. So this time we couldn't start before half past 4. Yeah. Actually, when the truck arrived, it was too tall to fit in the parking space. So we ended up rolling the flight cases down to the ramp ourselves. And yeah, I really hope this afternoon they managed to send a van not taller than 2.6 meters. Otherwise, we might need some volunteers. So talking about the meeting infrastructure, this is how it looks like. Actually, when we got the flight cases, the setup went pretty fast, as the hotel infrastructure is really good, and their patches are all labeled correctly, and they work. And yeah, so this is how. Yeah, that's strange, right? Yeah. So the physical infrastructure, the hotel allowed us to place the equipment in the server room. So not this server room, but this server room. Here you can see the switch is sitting on a comfy chair. And this is the other server room, patch room. We are looking into replacing some of our access points with something more modern, which can handle more clients, so we can bring less of them and still provide a very good experience. However, the 3 new access points we got at the beginning of the week didn't give us the best experience that we are used to. They get very hot, and they caused some intermittent issues with the 6 GHz capable devices. So we replaced it on Tuesday morning. Those are the details on the Wi-Fi networks. Unfortunately, the hotel couldn't switch their Wi-Fi in the conference area because they run their infrastruture over it. So maybe some people are still using the hotel Wi-Fi, even if you have to type the password like 100 times a day. We still see a few people using the legacy network, and we are very curious as why you do that. So if you're one of them, you can approach us or send us an email about it. The IPv6 mostly Wi-Fi is being adopted by other events, and we are very proud of that. If you haven't done so, go look at the presentation about it in the IPv6 working group. There are still some very small issues, like, for example, the macOS couldn't boot from the internet recovery from some obscure reason. We don't know yet, but everything that we use is open source technology, and yeah, you can see the details. The presentation system, this is how it looks like. Those are the components that we bring in each room. And so the brain of the system is the HDMI switcher, the big thing here. And where we input the Mac Minis and the Raspberry Pis, use it for the stenography. The outputs are then sent to the main projector and the side projector, and so we can switch the profiles when we want to change the presentations. The HDMI over Ethernet extenders are used to bring the video to the lectern screen, which is here. And also, we provide an HDMI cable on the lectern so that presenters can use their laptop to make exciting demos. Some statistics. Those are the number of the network during the week. Unfortunately, we don't have IPv4 against versus IPv6. This is not available on Linux, so when we switched from FreeBSD to Linux, we lost this data. We still have to figure out how to do it. Okay, thank you. The number of devices that need the dual stack are decreasing. We see a little trend here, and they are around 20%. Those are the NAT64 sessions. We use 256 IPv4 addresses for the NAT64, but yeah, we could still fit behind one single IP address if we want. Interesting figure here, like a middle finger. On Monday, we wonder if somebody did it on purpose, so maybe. So you can see that virtually every device now supports Wi-Fi 5, which is the AC standard. You can also see a significant support for some newer standard on Monday and Tuesday morning before we remove the new access points. So, yeah. Those are the number of connected devices. Yeah. You can see something happen on the Wednesday night. I wonder what is that. And those are the access points, same as last meeting. The one near the coffee station is the most used one. It's also where we placed the new access points initially, because we knew that would happen, so we wanted to stress them a little bit. So yeah, you can see the new one is the yellow one, and we replaced it with the blue one after that. We haven't got any complaints about the Wi-Fi, so also probably because the toilets were well covered also this time. And it's the first time we put an access point on the terrace on the first floor. That was a successful trial. And actually, we did get one complaint that the network was not available on the rooftop pool. So yeah, we're going to learn from that. Those are finally the barista stats. Yeah, they talk about themselves. Yeah. So I want to thank our other teams that work during the meeting. So Mitego, we work very closely with them. They do an amazing job, and they are also using open source technology. Antonio and Tobia are on site. Thank you very much, guys. And also. The stenographer team, they always do a very, very nice job. I love when they do that, so I don't do that. And lastly, the host, Dora and Assis, who helped us to getting the connection running during the week before the meeting. Thank you very much. Yeah. And yeah, one last thank to all our colleagues who are in the Amsterdam office. They work also with us to prepare the meetings, and they support us during the week. So thank you very much, guys. And I really love you. And I can get a few questions.
Yeah, we have time for questions.
Yeah. Hi, Dmitry Koch, speaking for myself. Well, I'm so helpful that increased member fees can allow the technical team to bring the rooftop pool in. I really appreciate the service. I mean, I'm expecting that to be at every next meeting, right?
I think so.
I mean,
yeah,
I think you can do it. Look, after this truck incident, you know, thanks. But seriously, thanks a lot for the Wi-Fi. I didn't use the one in the toilet, but I heard it's great too. Thanks.
You're welcome.
Maria?
Maria, a graph or chart enthusiast, would you please also the next time bring a chart of the barista over time, please?
Yeah, we do. Yeah, I didn't have time for that, but I will do it. Yeah.
Wi-Fi user and legacy user, actually. It was, I think you stumbled on a bug that we have on some Motorola phones that doesn't see the 5G network, and that's why I use the legacy. But all the rest did work really, really well. Thank you very much for that.
You're very welcome. Thank you.
I see no other questions. So thank you very much, Andrea, for the presentation and for whatever you did during the week. So this concludes the part where the program committee decided the content, or on the content, and now I will hand it back to Miriam. So thank you very much, everyone.
Thank you. Thanks for running this morning session. Yeah, before I start, I would apologize for a piece of fake news I apparently spread yesterday about the barista. Magically, they did show up this morning, even though we were told that they weren't available. So I'm sure you are very happy about that. And yeah, I think Neil, the vice chair, he's also here in the room. Yeah, I don't know if he wants me to announce it, but he became a grandfather a couple of days ago during this meeting. Very exciting. First grandchild in the family. So, right. So let's get started with some statistics. Yeah, you see here a number of attendees, you know, on site and online, really good numbers. Also in the top 5 countries, Portugal, luckily, and obviously that's why we're here, to reach out to the local communities. And we also had a lot of newcomers and also actually a lot of involvement from newcomers in some of the sessions, the DEI sessions, the mentoring discussions we had. So that's great. So I'm always interested to hear feedback from newcomers, particularly also from others, of course. We also had these 2 local hubs that I announced in the opening plenary. Thanks for organizing them. Here's a picture of the one from Poland. So they were participating a couple of days during the week together, as you can see there. I'm sure that was fun. Yeah, again, the RIPE Code of Conduct team, you already saw the presentation here. Again, thanks to the team for, you know, helping us to keep safe during the meeting. And again, a special thanks to Randy, who has been on the team from the beginning when we set up the Code of Conduct team and was a great help on the team. Click. More thanks go to some outgoing working group chairs. William Sylvester, the database working group chair, who has served in this role for a long time. I don't know if you're in the room, William. Don't see him. There is Peter from the IoT working group, who stepped in Rotterdam when nobody, you know, when Peter Steinhauser was on his own, he stepped in to serve one term, and he stepped down again now in the IoT working group. I don't think he's at this meeting. And then, of course, we have Doris Hauser in the DNS working group. Doris, I think I've seen you in the room. Can you come? I have a little gift for you. I have a little gift for William as well, but he's not here. So thanks, Doris, for serving in the DNS working group for a few years. Then on to the incoming working group chairs, 3 women in DNS. Doris will be, you know, followed by Evgenia from the. She wasn't here. She participated remotely, so she's probably not in the room. Maybe following remotely. Then we got Anna Maria in the IoT working group, who was here earlier this week but had to leave already, so she's also not present. And then in address policy, Franziska is joining as a 3rd working group chair. So thank you for agreeing to serve as in these roles from now on. So we'll hear more from you, I'm sure. So that means the whole group of working group chairs from at this point, from this meeting on, you can see here on this slide. And they will be, working on the agendas and the topics for the next meeting, of course. And again, big thank you to the to the PC, to the program committee, who was responsible for a fantastic plenary program. I think this time I had a lot of good feedback about this. So thanks to the PC for a great program earlier this week and until today also. There were two slots or two terms ended at this meeting. It was Clara's and Doris, and they were, they can serve another term. So in fact, Clara was re-elected on the PC. So I'm not going to give you a gift quite yet, I think. And Amedeo was selected on the to replace Doris on the PC. So thanks again. Also, thanks again to Doris for serving in two roles at the same time. So please don't forget to rate the talks. You can rate both the plenary talks and also then the working group talks. You can see a link on the main website. It will then, the main Vibe 90 website, which will guide you to the meeting plan, and then you can rate the talks on the meeting plan and each session. We'd also like to hear from you and like you to give us feedback. So I'll leave that up for a little while if you want to copy that link or scan that code, so you can do it straight away. So you don't have to send you reminders afterwards. Of course, you can also come talk to us, talk to the meeting team, registration desk, or to myself. I don't see anybody pulling out. Oh yeah, I see some people now pulling out their phones, scanning the code. So I learned that from Hisham last time at the SE meeting. He did that trick and kept the slides on and on and on. So people started to scanning the code, and we got a good share of feedback for that meeting. So yeah, please tell us what you like, what you didn't like, what we can improve next time, obviously. And yeah, at the end, I would really like to thank all the hosts and the sponsors, the host and all the sponsors again. The .pt people, they were a great help, as Ondřej has already mentioned, in preparation of the team. I think I have a gift. Where is our house is running? A gift for the hosts, and I also have a gift for the a platinum sponsor, AWS. And there is Kajal. Wow, this is the gift for you, for the office, maybe, to put it in. Thank you so much for being the host for Vibe 90. Oh yeah, you can put it back in the box. And we have a gift for, oh, there's another one, there's another piece of it. And I also have a token of appreciation for AWS as a continuing platinum sponsor, Clara. Thank you. Oh. Thank you. And that brings me to the last slide. Next Vibe meeting will be in Bucharest, Vibe 91 in October. And I believe we have as the next speaker the host of Vibe 90. So I'm happy to announce that Interlan will be the host for the Vibe 91 meeting in Bucharest, and Eric is already standing there. So this is it for me. I hope you enjoy the rest of the day, the lunch, and have a safe trip home or a great weekend in Lisbon. Yes, question. I didn't have a question slide.
Since we have a nice photographer here, where do all the pictures end up? because I think we have a lot of nice pictures, right? And
That's...
I also would not prefer a social media platform.
Do you want to answer that?
Yeah, hi, Philip Oldham at CC Web Services team. Yeah, they'll end up on the Ripe 90 website in a couple of days, so please do check, and as always, give us feedback. Thanks.
Ulka Atle, Ripe NCC, just adding something to what Phil said. We publish the photos in a low resolution. If you're a speaker, we've been told by the web team it helps pages load better. If you want a higher resolution photo of yourself, please email us. Thank you.
Excellent. Thanks for the responses there. And if there are no other questions, then yeah, I'd like to hand over to Eric. And I hope you had a great week.
So where are we going next? Of course, Ride 91 will be in Bucharest, Romania. So we will travel from Southwest Europe to Southeast Europe. Bucharest, the Romanian spelling is capital of Romania and the largest city in the country. It has a population of almost 2 million people. It's a major tech and business hub in Eastern Europe. It has a rich history and diverse architecture, maybe too diverse. And it's known for its vibrant nightlife and its cultural events. And of course, it is the host city of Ripe 91 in October. Romania is a country at the crossroads of Central and Eastern Europe, and it's known for its natural beauties like the Carpathian Mountains, the Danube Delta, and the seaside. And it's also home of the famous castles and fortresses, including the medieval Bran Castle, which is known as Dracula Castle, Palace Castle, and also the fortified churches in Transylvania. It's a nation with rich cultural and historical heritage. It's shaped by surrounding cultures, which is reflected also in its traditional cuisine and award-winning wines. It's, of course, a member of European Union. We are also in the Schengen now. And major cities like Bucharest, Timișoara, and Iași are also important centers for business, research, and culture. And now a few words about your next host. Interlan was founded in 2005. It's in the largest internet exchange platform in Romania. We bring together more than 130 ESNs from Romania, from the region and beyond. We are hosting some key infrastructure, root servers, TV exchange, route collectors, and of course, we are a proud supporter of the Ripe community. And Interlan Internet Exchange is operated by Interlan Association, which is a not-for-profit organization dedicated to support Romanian internet service providers. And of course, we are excited to welcome you to Ripe 91 in Bucharest. As part of our community involvement, we hosted a lot of events until now. We host the roadmap meetings since 2014. We hosted the UX forums, Ripe meetings, Ripe regional meetings, ISOC meetings, and this year we will host major events in Bucharest, the European Peering Forum in September, and of course the Ripe 91 in late October. And we want to propose for the next SE meeting to have a meeting in Constanța at the seaside, but it's only a proposal, so stay tuned until an official announcement will be made. This is our team that will be present at the next important events. So if you have questions about the next meeting, the next Thrive meeting, the next meeting that we are hosting about interbank net exchange or just about the Romanian market, you can find these guys at the most important events, including the two events that we will host, of course. So, see you in Bucharest, and we look forward to welcoming you. Thank you.
Thank you so much, Eric. We're all looking forward to that. And last but not least, I would give a big applause and big thank you to the RIPE NCC meeting team, who's actually made all this possible in the background. So we got Hafsa here on the left, and Sandra and Kajal, and they're the magic in the background. So thanks so much.
Thank you.
Some true words right there. Maybe a lot. Yes. Wait. Welcome to the secret working group. O grupo de trabajo secreto. I hope I didn't butcher that too badly. I have a clicker. So, the secret working group, what does that mean? Well, it means no pictures, no text messages, no clicker, no Facebook, no Telegram, no Twitter, yes, Twitter, no YouTube, no Instagram, it's hard to keep track of these logos, no TikTok, no WhatsApp, and also no why. Don't ask me why. There's one thing I'd like to clear up a little bit, because that may have been lost in the midst of time, is the why of the secret working group. Trying to come up with a good analogy for the secret working group. This is where I ended up. This is a rusty piece of metal sticking in the ground. This is a grounding pin. And the purpose of the grounding pin is to take too much tension and put it back into the ground. And that's also what the secret working group does. We are very serious people during the week, but we shouldn't be taking ourselves too seriously. And if people start taking themselves a little bit too seriously or something goes off the rails, we're always happy to help out. So that's that thing, and I hope that clarifies a little bit. Then next, you may have seen this lovely character around all my slides and hasn't been very clear. This is Sparky, and Sparky has been bravely assisting the secret working group for many meetings now. And we thought just to have Sparky introduce himself and actually say, who's Sparky according to Sparky? And this is what ChatGPT had to say. Sparky is the unofficial AI mascot of the secret working group presentations at REC meetings. It is typically represented as a somewhat forlorn looking robot, his words, not mine, often tucked in the corner of a slide. The presence of Sparky signals to the audience that AI was involved in the creation of the slide, whether it's text, imagery, limericks, or anything else. I don't know what the anything else is, but again, his words.
That's
not mine.
scary.
It's terrifying. Then on to the stuff you're really here for. I don't want to talk about the secret working group too long, because I don't know why. Your ticket is in progress. I'll do this one. The IT support desk saved the day, though not in a rapid display. They murmur, well, okay, then wander away. But your bug would be gone by next May. Here we are. Apologies, Rudiger, this was just too good. Speaking of too good, swim read. Do we have maybe someone over there who wants to read that?
Okay, go on. I heard of a guy called Jim who went for an unexpected swim. Nobody was hurt, and they gave him a shirt, but it said lifeguard just for him.
And the secret working group has been informed that there are still people looking for his glasses. Back to more serious stuff. This normally doesn't happen during the secret working group because the editorial process for the secret working group is usually in very well smoked back rooms. But there's a note from the editor to respond to significant suggestions and feedback that we've received during the week. It's about that thing. The secret working group has been absolutely flooded with suggestions to discuss a certain specific topic in any way possible. But after due consideration and checking with legal counsel, secret working group decided not to publish. Mostly because even though this topic may be considered absolutely hilarious by some, it is fundamentally not funny. Now, looking for words to better describe the situation, we could turn no further than our friend Randall at XKCD, who had this to say at some point. If you're yelled at, boycotted, have your show cancelled, or get banned from an internet community, your free speech isn't being violated. It's just that the people listening think you're an asshole, and they are showing you the door. So there you go. On to other riveting things. Internet of toilets. I mean, I don't know. And in a way, I feel seen. But what is the community's fascination with bathrooms? I mean, this is I think the fourth secret working group session in a row where I end up talking about connectivity in bathrooms. And actually, I mean, thinking about this a little bit longer and having to stand in line at the bathrooms while someone's doom scrolling while sitting down, I guess. We might have come to the point where this is a bug and not a feature. If people start looking for outlets, we should say no. And maybe the access point should also be, you know what, take a moment of zen while you're in the small room. I mean, your phone doesn't need to be talking to you. If that's your problem, then maybe, you know, actually talk to someone. I don't know. Right. What else do we have, Jan? Oh, yeah. Oh, yes, we have SWG2NG about de-accreditation. Oh, God. Yes, one more presentation about this document. Here we go. It's the criteria for the establishment of SWG-related platforms. The original document, as you all know, SWG2, was originally drafted in September 1642. We're not exactly sure on the day in September. It's a little bit lost. But there it had, I mean, it's been working for a very long time and is working pretty well, but it was missing the quality checks and reaccreditation parts of it. And you know, at some point you have a platform and it just no longer fits purpose. And what do you do? At the end of the day, we need to talk about preserving secrecy. So that's what we ended up doing. And so the principles have previously appeared. I mean, they don't get discussed, they just show up. And we had a closed consultation because obviously, the back rooms are now being refilled with smoke. And as a result of SWG2NG, which is an absolute dragon to speak, yeah, I have some sad news to report to you. There we go. There we go. Splat has failed reaccreditation and is now being decertified as a secret working group platform. First of all, it was no longer secret. Second, it was not doing all that much. However, due to recent political developments around the world, we are now happy to announce that there is now an official messaging platform for stuff that is supposed to be secret, which, of course, where is Signal? Hi, Meredith. Miss you. Now it's time for some culture. As you know, the secret working group also has a piece of culture in it, and we usually would have our esteemed Nigel write a sonnet and read it out. And he was hoping to do one last time over here, but unfortunately he couldn't. So we gave the job to Sparky instead. So I hope you'll indulge this one. Well-oiled. And I'm going to butcher a sonnet because I'm not an English person, so you know. I'll try anyway. The sun rose bright on Lisbon's river bend, where fiber met tradition, friend to friend. The tiles still gleamed, the seafood hit just right. But this year came with polish, edge, and light. The slides were crisp, the logos bold and clean, a smoother stream than we'd ever seen. From stage to sticker, all the branding sang. A subtle vibe that carried real ride clang. And there we go, back one. Old hands returned, surprised at all the flair, yet comforted to find the core still there. We talked, we laughed, we drafted ICPs, but lingered longer at the wine and cheese. Those sessions end and badge lanyards unwind. The links we are made are what we'll leave behind. So, Rob, I think we had another one. Do we? Okay, well, let's see. Making plans. Rob, all yours.
When twilight falls on rooms once full of light, where routing jokes and limericks took flight, your voice, dear Nigel, brought a steady tone to humor's stage and wisdom's quiet home. For years, your pen has moved with graceful flair. Through topics dry, you found the rhyme and care. Your sonnets stood where meeting notes grew long and turned the week's events to cheerful song. No BGP mess shook your calm control. No mailing list could ever shake your role. But now you speak your final lines and go as others rise to keep the show in flow. Though you move on, your rhythm stays in law. The secret lives, but we will miss you more.
So if you go read, something exploded. And it wasn't me this time. So if you go back into the dark history of the secret working group, you'll recognize what this is. It's a database object. And we don't keep them around. I mean, we're not updating much of them anymore, but we figured. There's a little bit extra content if you subscribe to our Patreon. If you go look at the database. Then, Jan, you had something to share, I think.
Habemus princeps. The Nomcom met in a smoke-filled room where ballots flew under chimney's plume. When the choice did emerge, like thick smoke gray surge, the new chair stepped out of the Zoom. Metico.
Yeah, I mean, try finding something that rhymes with meets echo. Absolutely terrible. Then finally, I don't know if you've all realized there was a bit of we had a lot of decor and branding around. There was one thing that was sort of not completely in the right place during the week that we sort of corrected during the coffee break this morning, and that's this. We're all children at heart. Then indeed, next time we'll see you in, no fear, Eric, see you in Bucharest.
Well, despite, as usually, carefully mailing around our agenda, my esteemed co-presenter missed the thing. So let's go to an AOB in order to be in line with our agenda. We need to talk about boards because, the secret working group tries to keep track of the relevant topics in the community. We are around here and we try to see what's going on. And this time it was all about furniture, boards, chairs. So we took a step back and we're trying to figure out what you were all talking about. And okay, there are so many different boards, composition, purpose, various level of helpfulness. You never really know. And something we didn't see before, we got a call, but it was not, it's probably in line, but we were a little bit confused. We got a call from the board. And they have a note of approval. And as we are doing and following due diligence, we are now reciting the note of approval of the Secret Working Group Supervisory Board. The Supervisory Board of the Secret Working Group has formally approved a significant step forward.
One of the Secret Working Group's core members, redacted, has concluded a series of demanding external commitments and will now fully refocus on the mission of the Secret Working Group.
This decision marks a positive turning point for the group. The member, long valued for their insights and dedication, will channel their renewed capacity to reshaping the Secret Working Group itself. Their first assignment is to help lead a restructuring effort aimed at re-strengthening the group's operational model and long-term relevance.
The format of the restructuring process is still open. It could take the form of a task force, ad hoc committee, BOF session, or another flexible, lightweight, community-driven setup that best fits the secret working group's needs.
And we're left with these closing remarks, so don't worry. The old tasks were just the simulation speaking. Welcome to the real world.